Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. Here we are with chapter 2 of microwave engineering. The very popular two cavity klystron is covered, and we started the concept of extended interaction to have improvement into the efficiency and the gain with the help of multi cavities. Hence the device is multi cavity klystron. Based on to the understanding of its working and few of the parameters of measurement, we have solved two problems also. Now let us have the formulae for the output power with respect to this device if the four cavities are concerned. So here the four cavities if we consider, so that time the structural diagram of the multi-cavity klystron amplifier can be given by the diagram that already we have covered. I get back to the diagram here. So this will be the diagram here. So in this diagram, the first one that is provided with the RF input will be the buncher cavity, and I mark it as number 1. The second cavity will also contribute in velocity modulation by the bunching. The third cavity will also be contributing by the velocity modulation, and fourth cavity that will be acting as catcher cavity and will be providing the RF output that will be having maximum amplification, and comparable it will be having more amplification with respect to the two cavity klystron. This will be the cathode end and this will be the collector end. The specified polarities of the electrodes are negative and positive respectively. So here we shall be calling the first re-entrant cavity. Here we have taken the toroidal cavity as the input cavity, second and third as the intermediate cavity, and the fourth as output cavity. Now as the input of the first cavity goes to the second cavities along with the electron beam focused from cathode up to the collector here. So here the induced current and induced voltages can be formulated here. Now here we go for the convection current for the second intermediate cavity, that is the third cavity into the diagram, and it will be given by the formula. Here we shall be writing it as I suffix 3 and we shall be taking it as a mod here, and it will be 1 upon 2 capital I0 into omega divided by capital V0 into omega Q into beta 0 into the mod of, here it will be V2 here. Now in this formulation we have the parameters like I0, this is the DC beam current, electron beam current. V0 is the DC potential applied between cathode and the collector. Omega is the angular frequency. Omega Q is the reduced angular or plasma frequency. Beta suffix 0 is the output beam coupling coefficient. Here it is very clear that as per as the manufacturing of the two cavity klystron or the multi cavity klystron, in our case the four cavity klystron is concerned, the input and output re-entrant cavities are identical into the structure. So the beam coupling coefficient, either you denote it as beta suffix I for the input cavity or beta suffix 0 or O for the output cavity, are same here. Now we have V2 in mod here. So this is the magnitude of the RF output voltage taken out from the catcher cavity. So this is for the second intermediate cavity. So further it can also be mentioned in terms of 1 upon 4. Here we have I0 omega divided by capital V0 omega Q bracket square, beta 0 it will be having the power of 3 into V1 into RSH here. So in the equation RSH denotes the shunt resistance here. Now the output voltage of the same second intermediate cavity can be given by the equation. So this equation will be mod of V3 we denote, and will be given by beta suffix 0 into mod I3. So this is the last equation for mod I3 into the multiplication of RSH here. So this will also be 1 upon 4 in multiplication to, here we have I0 omega divided by V0 omega suffix q, that is squared. Beta 0 will be having the power 4 here in multiplication to mod V1 into RSH square here. So as this was for the second intermediate cavity, that means cavity number 3, the same we can extend up to the cavity number 4, which will be our output cavity here. Therefore, the RF convection current for the fourth cavity or the output cavity can be denoted as, it will be mod of I4 here, and will be computed as 1 by 2 in multiplication to capital I0 omega divided by capital V0 omega q into beta suffix I here into mod of V3 is equal to 1 by 8 I0 omega divided by capital V0 omega q, bracket will be squared, it will be beta 0 to the power 5 mod of V1 into RSH square. And the fundamental component of this current can be denoted by mod of capital I4 is equal to beta 0 into mod of I4 here equal to 1 upon 8 I0 omega divided by capital V0 omega q, it will be cubed here, beta 0 will be having the power 6 this time, and mod of V1 into RSH square here. So this will be the fundamental component of the current with respect to the output cavity, the catcher. The output voltage next to it can also be written in the same form. So it will be mod of V4, the multiplication of mod of I4 from the previous equation into RSHL. So this will become 1 by 8 I0 omega upon V0 omega q, it is cubed here, into beta 0 to the power 6 mod of V1 into RSH square into RSHL here. So here RSHL is with respect to the shunt resistance including the external loading, so that we can take out the RF output here. Finally, the output power can be denoted by P suffix OUT, and it will be mod of I4 having the power 4 into RSHL. So it will be 1 upon 64 in the bracket, here we have I0 omega divided by V0 omega q, that is having the power 6 now, into beta 0 to the power 12, it will be 6 to the into V1 mod square into RSH to the power 4 into, here we have RSHL to the power 2 here. So I outline this formula. This formula will be applicable when we compute the values of output power for 4 cavity klystron in the next lectures. So in the next lecture we shall be solving problem number 3 based on to the multi-cavity klystron. So I hope you are getting the knowledge and will be practicing for the problems for microwave engineering. So for more information like this, you can subscribe to Ekeeda channel. Thank you.